Okay, so we have the question. It comes from later. We have the question, if f of x is this function, let's find f of 550 over f of 350. Well, f of 550 over 350 is 12.5 times 2.0075 times 550. And most people wrote that down. That some people didn't write it down, got it correct. Divided by 12.5 times 2 to the 0.0075 times 350, right? Make sense? Well, now 12.5 is a common factor. So you divide 12.5 by 12.5, right? So that equals 275 times 550 divided by 2 to the 0.0075 is 350. Now at this point, you could plug this in. Of course, a lot of people plug the whole thing into a calculator. But since the 12.5 divides out, it was unnecessary to do that. Although if you did it correctly, which I think everybody pretty much did, be okay. But I'm trying to make a point is you want to simplify this. Okay. And you can actually simplify this. How could you simplify this? Well, you're dividing 2 to one power by 2 to the other power. You do have the rule of exponents. It says to the y equals a to the x minus y. And if that's not totally familiar to you, you really need to review the rules of exponents because you'll be stumbling over it with exponential functions. Exponents are really important for exponential functions. Okay, so make sure you understand these rules. I developed them in the intermediate algebra course. And if you want to look at that, you can, but just one way or another, review your rules of exponents and make sure you know how to use them. Okay. So anyhow, here we have it, and I'm gonna do that. I'm gonna say, well, that is Q 0.0075 times 550 minus 0.0075 times 350. And I'm going to erase this because it's going to be in my way, but I just write it down to remind you what I'm doing here. 2 raised to this divided by 2 raised to this is 2 to this minus this. This is 2 to the 0.0075 times 550 minus 350 equals 2 to the 0.0075 times 200. Okay. And this equals, if you do the multiplication, you get 2 to the 1.5. Approximately 2 to the 8.28. Now, a lot of people ended up with this. I think most of you ended up with this number. That's good. Okay. But you see that it could have been done a lot more simple. Okay. Now, you might not think that's simple. But by simpler, I mean, you can reduce it down a whole lot before you actually evaluate the number. It comes down to 2 to the 1.5 power. Okay. So you want to understand the algebra of that because you're going to have to be doing that in the pretty near future. I'll tell you where all this came from in a minute and show you some really don't have mistakes that I made, although I corrected most of them. Let's look at f of x plus h. What's f of x plus h? Well, x becomes x plus h, right? So that this x becomes x plus h. So you're going to get 12.5 times 2 to the 0.0075. And write out the x plus h. I don't have to. Myself a little more than okay. F of x plus h equals 12.5 times 2 to the 0.0075 times x plus h. That's all. Okay. F of x plus h minus f of x is 12.5 times 2 to the 0.0075 times x plus h minus 12.5 alpha. Still don't have enough room. Minus 12.5 is 2 to the 0.0075 x. Okay. Can I simplify that? Well, there are a lot of ways I can simplify it. I can write that as 12.5 times 2 to the 0.0075 times x plus h minus 2 to the 0.0075 x. Factor out the 12.5, right? Something else I can, by the rules of exponents, I can write this as, and I didn't expect anybody to do that. I didn't say this. Okay, you wrote out this, I'm totally happy. Okay, but next time I'll be totally happier if you can apply the rules for exponents. Things like practice that on. Okay. I'm going to do something over here because if I do it in line here, it's not confusing. So I just want to take this expression. Let's take the expression 2 to the x plus h. 2 to the 5 times x plus h equals 2 to the 0.0075 x plus 0.0075 h. Everybody will agree with me on that because that's just a straight distributive multiplication over division, right? So that's not going to be an issue. for anybody. Let me move the camera a little bit because it's not where I expect it to be. The reason it's not where I expect it to be is I didn't move it there in the first place. Okay. No fault of the camera, no fault of the university. Okay, so we get this, right? Now, what's your formula for a to the b plus c? What's that? Intermediate algebra students know it right now. I don't know if they'll know when they get to the pre-calculus class. They're probably going to forget it. So perhaps many of you forgot it. Okay? So I'd expect some of you did. That's a to the b times a to the c. Why is that? Square times x cubed means x times x multiplied by x times x, which is x to the fifth, right? So x squared times x cubed equals x to the 2 plus 3, right? Well, that means a to the b plus c equals a to the b times a to the c. This is just an example of this, right? Now, if we apply it to this expression, and I'll tell you, I know this can look a little strange. I mean, I had really, really solid algebra 2 skills when I was taking calculus. And when I got to this, the context was just so weird that algebra 2, that little bit of algebra 2 just went out of my head, even though I knew it perfectly well. So if this looks a little weird to you, it looked a little weird to me when I first saw it, although I picked it up right away. Okay? If you're pretty rusty on your rules of expert, you might have to think about it a little more than I did, but I didn't have to stop thinking about it. So be alert. This is totally trivial until you see it. Well, actually, could you write down what that would be in terms of this rule? I'm going to give you 1 minute. See if you can write down, don't copy the rest of the board. Just stop right here, write this expression down and write what it's equal according to this rule of exponents. Class doesn't have this, but this is A is 2, B plus C is this plus this. You're going to write A to the B, which is 2.0075x times 2 to the 0.0075h. That's an application of the rules for exponents, and you really do need to know them. Okay? So I can write this as 2 to the 0.0075 x multiplied by 2 to the 0.0075 h minus 2 to the 0.0075 x. Okay? Can you see what I wrote down? Instead of this expression, I wrote this expression. Now, what can I do with this expression inside the parentheses? You notice that I have 2 to the 0.0075x here, and I have it again here, right? So I can factor it out. That's going to give me 12.5 times 2 to the 0.0075x multiplied by 2 to the 0.0075h minus 1. Now I want you to ponder that algebra. Okay? The algebra in this course doesn't get a whole lot harder than it is when you're adding rational expressions or when you're dealing with exponents at this level. Okay, if your algebra is up to those things, it's probably gonna be pretty much okay when you get to calculus. Okay? We're not trying to teach you algebra in this course, but I'm going slow through some of the algebra because I know you're rusty on it. And I know that it's pretty easy to get through an algebra 2 course without really knowing algebra 2. Okay? You learn some things, but the really important things just don't get retained because you're not asked to do it at the level you need to. Okay? But you do get enough if you do a good job in your algebra 2 course to be able to see where it fits in and refresh yourself to the point where you know what you need to do. Okay? So don't feel any shame if your algebra 2 is rusty, but do whatever's necessary to get it up to the level that you need it for this course. Okay? And then there's still a couple of jumps to make in calculus, but you'll be in a position to make. All right, so you're going to see this again, but in some like right here. So all I asked you for here was this. Didn't ask you for the rest of it, but I showed you the rest of it. Right? If you got this, I'm happy. If by the next time you've got these ideas, I'm ecstatic. Okay? Review it. And then for f of x plus h minus f of x, of course, you wouldn't write down this, and then you wouldn't write down your minus expression for f of x. So actually, these two things are the things I asked with them. And then I went crazy with it. Okay. Now, I'll show you a couple of bonehead mistakes. Something's caught in my throat. In the MDE class, and this is kind of question you can expect. So, yeah, I could expect you to be able to do this right now. But let's go over it briefly. It said construct the exponential shape in a rectangle. I'll construct the exponentials, right? So you see here, I constructed the exponential shape. I took a rectangle, I subdivided it. Then I labeled it, but I didn't ask you to label it. So the first step would just be construct the exponential graph, and everybody, or almost everybody, is pretty good at doing it. You got to be perfect at doing it. Okay. And the ones I saw in the MD 61 class, perfect, much better than mine. Okay, that's what I want to see. I'm limited how well I can do this with chalk, and also the fact that I do it fast and I'm not particularly careful. Because I want to show that there are uncertainties in these things. I don't want all my results to be exactly right. Okay. And even if I wanted them to, on this, making honest estimates of a graph of this size, I wouldn't be exactly right. Matter of fact, it's impossible for anybody to be exactly right on some of these estimates because the numbers are irrational. They're decimals that just go on forever. You can't get it wrong. But you want to get it close. And everybody's gotten it closer. Okay, so it's a construction. Then the rectangle has dimensions 200 by 800. Now, y versus x is the way we graph things. So I give you the y dimension, then the x dimension. And I gave it backwards because I didn't specify which was y, which is x. And some people drew the other. Okay? Okay. 200 by 800 is just fine instead of 800. Okay, it works just as well. So we went with 200 by 800, which means, well, then I say the red dots at the point 400, 0. because I didn't tell anybody that, but they kind of made it that way. And that was just fine with me. So red dot would be wherever x equals 400 is right there's the middle line. Now there's where I screwed up when I did a lot of what I did. Okay. Because I was thinking x equals 400 over here, and that messed up everything, including the function I asked you to do. Okay. That's no harm. You still see what the function is, and you still get a ratio, and everybody got, or just about everybody got the right ratio. Okay. So I was happy with that. Okay. So the red dots are 400, 0. So I said label the construction lines. Well, I'm not going to go over labeling the construction lines. I mean, yeah, real quickly. Making mistake after mistake. I'm writing stuff down. It isn't all that relevant. What I'm trying to get at. I take it back. Thought I made a mistake, but I did. Okay. Red dots at 400, 0. And I apologize. I don't know what it is. I didn't make all that many mistakes Monday, Tuesday. I hadn't had much sleep. Now I've had plenty of sleep the last couple of nights, and I can't do anything right. So don't be like me. If red dot is at 400, 0. Okay. So this thing has a width of 800, and here's 400. Here's the x equals 400 line. So we divide up from x equals 0 to x equals 800, and we get construction lines, vertical lines at x equals 200, x equals 400, x equals 600, and x equals 800. I think everybody understands that. Everybody in the MDE class did fine with it. Okay. And then the y values go from 0 to 20 because red dots have y coordinate 0. This is the line y equals 0, which is the y-axis, it turns out. Okay. And we go from 0 up to 200. Halfway from 200 down to 0 is 100. Halfway from there to 0 is 50. Halfway from there to 0 is 25. And halfway from there to 0 is 12.5. So our exponential graph goes from the y equals 12.5 point of this line over 1, up 1, over 1, up 1, over 1, up 1, over 1, up 1. It ends up great. So everybody knows that. And everybody, I think, can label those construction. Then I asked the question, you can review that video. I mean, kind of flip through it, see what you need to see if you need to do that. But I said between x equals 500 and x equals 700, y changes from 70 to 145 approximately. Okay. Well, that's an answer to estimate y when x equals 500 and x equals 700, right? And everybody knows how to do that. That's some people good at. Okay. Some people didn't remember to do it when I asked to on the test, which made the ratings lower than they should have been, but could have. Okay. You know, make sure next test you take, you do everything that's asked, because I'm pretty sure everybody knows how to do that. Okay. And not everybody did. Most people did. So we make the estimates. We draw the x equals 500 line, the x equals 700 line. There they are in blue. And here are the horizontal lines. And we estimate y equals 70 and y equals 145. Okay. Then I ask for the ratio, which is 2.07. Okay. Ratio means divide second one by the first one. Ratio of the second estimate to your first estimate. There's your ratio. That's the ratio of the y values. Make sure you understand what a ratio is. Another thing that I can't believe people come out of K through 12 not knowing. Okay. One of the most fundamental concepts in mathematics. Spent all this time learning how to factor, nobody knows what a ratio is. It's a lot more important than factoring, although factoring is important too. Okay, so there's the ratio. And then we do the ratio from 350 to 500, or like we do the same thing, estimate the y's, then we get y equals 45 and y equals 95. And the ratio is 95 over 45 is about 2.1. So you can say that the ratio is pretty close to 2. Now, people who did better graphs than I did came up with a ratio of 1.9 or 1.8. Still pretty close to 2, right? And it should be, because the graph is done perfectly and estimated perfectly, you're going to get exactly 2. Why? Well, let's look at what happens to the numbers here. If I write down a table of construction points, I mean, the y values are 200, 150, 25, 12.5, right? But in reverse order, yeah, half of this is this, half of this is this, half of this is this, half of this is this. Okay, which means between here and here it doubled, here to here it doubled, here to here it doubled, from here to here it doubled, right? Now, what did X do? Well, X went up by 200 and it doubled. Then X went up by another 200 and it doubled again. X went up by another 200, it doubled again. X went up by another 200, it doubled again. So your exponential graph has a certain doubling time. In this case, it's 200. Okay? So I can make a little annotation here. This is a big deal. 4 stars. I don't know what the 4 stars, bad star, but there it is. Okay? Make sense? You can see it from the table. You can see it from the way you construct these things. No matter how you construct it, if you do the construction the way we've been doing it since the first day of class, the thing will always double with each new X construction line, okay? With each new vertical construction line when you do the algorithm, okay? It's not true if you do too many construction lines. Remember, you've only got 3 construction lines between the left and the right edge with the exponential. If you're doing a squaring function, you need a couple more. You've got to subdivide one more time, and you know that. If you do that, then the table doesn't really show what we just showed. Now, it doubled here. Did it double between here and here? Well, the blue values were 70 and 145. That's from its graph. That's estimated from a graph. That's estimated from my sloppy graph. If it had gone from 70 to 145 to 140, it would have been double, right? Now, maybe it wasn't 70, maybe it was 71.6 to 143.2, I think. Okay? Well, we can't estimate that close. And between the 2 orange lines, the y values went from 45 to 95. Well, from 45 to 90 would have been a doubling. 45 to 95 is a little more. Somebody else might have estimated 50 and 90. Got 1.8 for the ratio. Still going to be close to double. If you do this graph even halfway carefully and do decent estimates, your ratio is going to be close to 2. For any 2 points that are separated by 200, because you notice 500, 700 are separated by 200, right? 500, 350, and 550 separated by 200. Okay? That's the most, at least the level of this course, it's the most important characteristic of an exponential function. And that's something you simply need to understand about exponential functions. Now, I went and screwed up badly because, I mean, I started out okay, I said, okay, the formula for the function, it's an exponential function, means it's a vertically stretched 2 to the x function, right? It's also horizontally compressed or expanded. And if you remember, the horizontally, I don't like the idea of compression factor because it can be an expansion. Just like if you vertically stretch by factor 1/4, it's a compression, right? So it just, the terminology is a little confusing. You just got to be used to. You did it in chapter 1, you might have to review it. Because we haven't used it, we haven't reinforced it, we haven't used it at all. So if you don't even remember seeing it, okay, go back to the section on transformations and see it now. Because we need it for exponential functions. The reason we haven't used it so far is we weren't going to need it until we got to exponential functions. There's no point in reminding you about it 2 or 3 more times because you'd have forgotten it 2 or 3 more times. Unless I was testing you over. Okay? So I decided we'll leave it to here. But now you have this horizontal compression. Okay, well, the function I gave you has alpha equal to 0.0075. That's less than 1. That's an expansion. If we do the toolkit exponential function, it's in a 4x4 rectangle, right? Well, this rectangle is 800 by 200. It's not 4x4 anymore. It's 200 times as wide as you would have for your toolkit function. Okay? It also shifted a little bit, but we don't do a lot of horizontal shifts for exponential functions because they're unnecessary. Okay? It's usually just vertical shifts and horizontal compressions. Okay? And you store that away, you'll see it as it comes up. All right. So anyhow, that's why I say then that this is I'm not sure what symbol your text uses. K is very often used, but that's also what you use for vertical shift. So we don't want to confuse K here with a K there. All right. So that's it. It's got 2 parameters, A and alpha. Okay, so what I've said is right there is an example of A times 2 to the A to the alpha X. That's your general function for what we're doing right now. Then I said y equals 12.5 when x equals 0. Well, then you write it out. You replace y by 12.5, you replace x by 0. So you got 12.5 equals a times 2 to the alpha times 0. And then you solve that. Now, too many people are going to solve that wrong. First of all, alpha times 0 is 0. And what's 2 to the 0? Okay, be careful what figure you use, but yes, okay. Any number to the zero is one. Again, here's an indictment of K through 12. People don't know this. Okay. Okay. So it makes it very easy to solve this. You get A equals 12.5. So now we know what number has to be in front for this function. Okay. Then I said if y equals 100, x equals 400, right? Well, that's where I did a real bonehead thing, because I'm looking at the graph over here, and I'm looking about here, and I'm seeing 100, right? And I don't see my x equals 400 line, which I labeled kind of small, which is right here, which gives me y equals 50, not 100. Okay? Make sense? So you can look at what I then went and did. It gave me the function that you used when we started the class. This thing always drives me needed. But we love humidity today. Okay, so I said y equals 100 when x equals 400. That was a lot. What I got was the function if this had been an 800 by 400 rectangle. Okay, then that would have been true. But if you look carefully at the graph and label it and make a bigger graph so you can actually read your labels when you're over here, or if you had enough sense to think about what you're looking at, which I didn't, you'd see that y equals 50. Okay, so it's right already. Come on, guys. I've got to change my 100s to 50s. That's going to change my result here. It's going to change my result here. It's going to change my result here. It's going to change this number here. It's going to change this number here. It's going to change this number here. So it's going to change this decimal. Of course, that decimal is going to become very obvious. So I'm going to solve it now. Y is 50, x is 400. We know that a is 12.5. We have y equals a times 2 to the alpha x. So again, x is 400. So alpha x is 400 times alpha, right? Okay, that's straightforward. Y is now 50, not my ignorant old 100. Okay. So we get, when we solve this equation, we divide both sides by 12.5. We get 2 to the 400 alpha equals 50 over 12.5. That should be obvious, and that's 4. Now, 2 to what power equals 4? Show me what power of 2 equals 4. Come on, everybody, show me. What power? Yeah, okay. What's 2 to the third? Is it 4? No. What's 2 to the fourth? 16. Yeah. Is it 4? No. What power of 2 equals 4? Second power. Okay. So 2 to the second power equals 4. This means that the power of 2 I've got here has to be 2. If this equals 4, then 400 alpha had better be 2, right? So we have 2 to the second. So 400 alpha equals 2. So alpha equals 2 over 400. Instead of 0.0075, it's 0.005. Okay. Now, if you were to come back, and we're not going to take time to do it, you're going to come back and do the same thing I asked you, do f of x plus h, f of x plus h minus f of x, and so forth. And where is it? I did it. More specifically, f of 550 over f of 350. Then you'd have 0.005 here times 550, right? Okay, so I'm going to write it out the way it should have been, and you can verify it using your calculator. I recommend you do that. It doesn't take long. I'm going to change my 7 5s to 5s. And I'm going to do all the simplifications. Okay, so that's 0.005, 0.005, 0.005, 0.005, 0.005, 5. Now, I think I've changed them all. I've done my simplifications. You could just take this expression, plug it into your calculator, divide by this denominator, plug it into your calculator, right? And you get a result, and that would have been fine. But now you need to see that I can divide the 12.5s out. And then I can subtract my exponents. And then I can factor the 0.005 out of the exponents I subtract. And I end up with 2 to the 0.005 times 200. What's 0.005 times 200? Well, 2 times 5 is 10, and you got a couple decimals. That's going to be 2 to the 1. And can you show me with your fingers what's 2 to the 1? And people have a hard time. Maybe you got a little arthritis in those fingers. Kind of slow coming up with it. But okay, yeah. Okay. 2 to the 1, which is 2. What does this tell you? This tells you that when x changes from 350 to 550, y doubles. How's that consistent with what I've been trying to tell you? X changes by 200, y doubles. As it did for the table that we get from the construction points. Okay, as it almost did for our estimates. Okay, so now we know how to get this function. Okay, if you have 2 points on the graph of an exponential function, you can always find a and alpha. But sometimes you got to use logarithms that you don't know how to do yet. Okay, that's coming up next week. So we have something to be excited about. Okay. Now I want to shift gears a little bit. Let's say that for this graph and for this function, which is y equals 12.5 times 2 to the 0.005 x. Y is a population of fish. Hopefully not, but maybe invasive fish that have invaded this pond. Okay? Make sense? And instead of x, it makes more sense. I'm going to talk about time And often with exponential functions, we use t because exponential functions are very often used for things that change with time. Okay, like for example, the number of bacteria and that stuff you got in the back of the refrigerator you forgot about last year. Okay, now actually, you probably have a saturation level of bacteria. If it was 3 weeks ago, you probably have an exponential increase in your bacteria, which makes it dangerous to eat stuff after a certain time. Now, I know my wife's been eating cottage cheese. It had a sell-by date back in early February, and she's still alive. Okay. Uh, and cottage cheese doesn't go bad that fast. If it doesn't have mold on it, it smells all right. It's probably all right, but you really shouldn't eat it. I tell her, I finally threw it out and bought her some new. Okay. You live through the last one. We're gonna cut this off, right? You can't explain exponential growth to you. But she came out of high school, she knew all the stuff that she went into medical profession. Yeah. You don't have to do a lot of quantitative stuff unless you're very thorough. Okay, so anyhow, uh, make sure we're still recording. Good. Yeah, why is fish population? T is time in days. So tell me, how many fish do we have at the start? Well, your answer is that would be t equals 0. Instead of x equals 0, it'd be t equals 0. Then you'd have 12.5 fish, right? And of course, if you plug in t equals 0 here, you get 2 to the 0, which is 1, and you get y equals 12.5. So the function tells you you got 12.5 fish, right? Now, how many fish do you have after a year? Well, you plug in 365 for t and evaluate it. Okay? And where's 365 in the graph? It's about here. It looks like we ought to be up around 44 fish or something like that after a year. Okay. How long does it take for the population to double? How does it take to get 25 fish? Well, one time is 200. Every time changes by 200 days, the number of fish doubles. Okay? Understand that? Okay, that's good. Thing to understand. Okay. So what can we do? Well, we can predict, first of all, and that's just because 2 to the 0.005 times 200 is 2 to the 1, which is 2, which we just saw. Okay. F of t plus 200 over f of t is always 2. You prove that by you being able to use the rules that we use to simplify the expressions we looked at. And this is pretty easily proved. Okay, you'd have to write it out. We're not going to prove it today. We've only got 10 minutes left. Okay, we could do that in 10 minutes, but there are other things. Okay, but examples of this are just that okay, it's on the back of this thing. Anyhow, what you do, f of 550 over f of 350. If t equals 350, we get f of 550 over 350, and we showed that that was 2. Okay. And we showed it on the graph too, approximately. We know that f of 700 over f of 500 has to be 2 now. We estimated 2.1, which wasn't bad, or 2.07. Okay, I estimated 2.07. Okay, and I'm proud of that. Okay, if t is 500, t plus 200 is 700. T f of 700, which we estimated to be 145, divided by f of 500, which we estimated to be 70, is pretty close to 2 by our estimates. And if we do it with the function, it comes out exactly 2. If we don't use any rounding off in our calculator, it should come out exactly 2. If you round off anything, it'll come out 1.999 or something like that. Okay? 2.0. So we understand that this works. Now, there's another property of this function that's important. It's that the steepness of this graph is just a multiple of the y value. If the y value is twice as big, it's twice as steep. What that means is if you got twice as many fish, you got twice as much reproduction and twice as many new fish. So the population of fish increases in proportional to how many fish you have. Okay? So I'm going to say this. Exponential growth over the, but what's it? The rate of change of y is proportional to the value of y. Example, the number of new fish is proportional to the number of fish. That's an inexact statement. I could qualify it, but I don't want to confuse you too much. Okay, it's intuitively obvious. If you got more fish, there's going to be more eggs. More eggs are going to hatch. If there's room for them so they don't eat each other, like 12 fish in a big pond, you know, the new egg hatch, fish disperse, and they don't get eaten any faster than they would if you had 125 fish, because there's plenty of room for them to escape and hide. Okay? And plenty of food for them to eat. Let's say it's a fertile pond. Okay? Make sense? Now, when fish start eating each other because they're getting crowded, and they start not laying as many eggs because spend all their time trying to find enough to eat and don't have the energy, they don't quite get enough to eat, they don't have the energy to produce the eggs and so forth, okay? All that stuff can happen and does happen when the pond reaches its saturation point or approaches its saturation. I'll even mention, this is very interesting, the way it grows is population goes up exponentially until that stuff starts to happen, then it levels out. Okay? And just to show you the board, if you're going to see it. It's a logistic model. It's kind of exponential down here, but then it kind of exponentially approaches a level at which it can't sustain, okay? And you can approach that otherwise too. If you got too many fish, the population is going to decrease. You're going to have a greater death rate than you got birth rate, okay? You can have that. It's very interesting. You can apply this bacteria. And don't do that. Don't try to figure out what the doubling time of your bacteria is in that chicken salad that you have in your refrigerator. It says throw it out after 5 days or 3 days, 2 hours, throw it out. Okay. Also, don't leave it out. If you are aware of what the food advocates tell you, or the nutrition or the health advocates, you know you don't leave food out warm because the bacteria, the exponential growth is much quicker. Keep it in the refrigerator under 40 degrees. That pretty much keeps a lid on it, but there's still some growth. Okay? You got to be careful. So there are reasons for these rules. Now, I break them all the time. And look what I was like. I'm 29 years old and I look like this. Okay? Oh, that's what happens if you don't follow the rules. All right. You get the idea. Now, your homework, I haven't given you a whole lot of information on how to solve the problems in your homework, but people usually do okay on this homework with what I'm giving you. What I've given you is a broader perspective of what all this means, because the homework for next time is see how this stuff applies. You're talking about animal herds, you're talking about maybe actually baby bacteria growth. Okay. I don't think there's one in the fish population, but any population is going to act like the fish population. Okay. I use fish population because it's easier to visualize a pond than an ecosystem. Okay. And the pond is often simple because you don't have predators. Of course, any fish is a predator to its offspring. Okay. All right. Well, good luck with that. This stuff that we're getting into isn't that bad if you know the rules for exponents and know how to apply it. And we're going to be seeing them and applied. The next topic we actually look at is logarithms. And I'll just give you a quick hint. Have an exponential. Here's a graphical logarithm. This is the inverse function of this. Logarithms are inverse functions of exponentials. The base 2 logarithm is the inverse to the 2 to the x function. There's also base e natural log. We'll talk more about that. Okay, you'll see e to the x, and incidentally, you have an e to the x button on your calculator. It's no different than using 2 to the x. It's just you got a button for it. So you don't have to plug in 2.718281828, then whatever follows that. Okay? That'd be a pain. And you have a natural log button and a log button. So a lot of this stuff gets a lot simpler. Okay. Got any questions? Stick around.